All right, number 28. We're going to factor it completely. First thing I see is that both 8 and 64 have an 8 in them. So you have x cubed minus 8. And then you have to remember, okay, x cubed minus 8. It's not x minus 2 cubed because you can't just distribute that squared, or sorry, distribute the cube. But it is our little factoring pattern of the difference of two cubes. This factoring pattern is going to be on your test. It's always going to be a minus b, a squared plus ab plus b squared. But you're going to have a formula sheet to help you out with this. And so you have x squared plus these two numbers multiplied together plus the last number squared, which is 4. And what's great is that you could type this factored form into your calculator, into the graph, into the y equals. You could type this original one into your y equals and see if they match. Moving on. So in this one, 28 and 7 both have a 7 in them, and then they both have an x. And you're left with 4x squared minus 1 is left over. And then this is a little different, but you've got the difference of squares. Something squared minus something squared. And so that's when you have the plus minus. 2x plus 1, 2x minus 1. Write the given radical using rational exponents. And so what we're talking about is how the 7th root is really something to the 1/7 power. And so you have 128 x to the 7th y, and so you could write it to the 1/7. But this also reduces because you can take the 7th root of 7, and 128 reduces because 2 to the 7th power is 128. And so the 7th root of 128 is 2. The 7th root of x to the 7th is x, because 2 times 2, 7 times, x times x times x, 7 times. And then you leave the y in the root, or you raise the y to the 1/7 power. All right, next one. Cubed root. Undo a cubed root by cubing both sides. So x plus 4 equals 15 cubed, which is 3,375. Subtract the 4, 3,371. You can plug it back in, add the 4, take the cubed root, you get 15. Here, if you square both sides, you get x plus 2 equals 16. Subtract the 2, you get 14. We're squaring both sides because now it's a square root. The problem is when you plug it back in, 14 plus 2 is 16. Square root of 16 is 4, and 4 is not equal to negative 4. And so if you had boxed this around, you'd have to cross it out because there is no solution to this problem. You can't ever take the square root of a number and get a negative number. It's impossible. Until you could have noticed it at the beginning. All right, 32. What's the y-intercept of this graph? Y-intercepts are when x equals 0, just like the linear function. So y equals 2 times 0 minus 4, 0 plus 4, and so that crosses out. You get negative 4 over 4. The y-intercept is negative 1. Or you could say 0, negative 1. All right, next equation to solve. Working our way to the x. The least connected is this 1. And so if you subtract the 1 from both sides, you get 2. Undoing the squared, because now the 8 and the 3 are trapped underneath the square root, so you have to undo it by squaring both sides. And when you square both sides, you get undo the square root, and you get 4. 2 squared is 4. add the 8. Add the 8 over, you get 3x equals 12. Divide by 3, you get 4. So you can plug it back in. 3 times 4 is 12. 12 minus 8 is 4. Square root of 4 is 2. 2 plus 1 is 3. And so, indeed, it checks out. Find the domain of this function. Again, just like we did it on the problem before, you have to worry about when the denominator equals 0 because you can't divide by 0. If you factor this, x plus 1, x minus 1, you'll notice that the domain is going to be everything except x can't be 1 or negative 1. How do you set that equal to 0? Added the 1. Just make sure when you take the square root of both sides, you get plus or minus 1. Sketch an accurate graph of the following. And so what we're talking about is the square root graph just started. Square root of 1 is 1. Square root of 4 is 2. And so it looks like this. Except this plus 2 shifts it to the left 2, opposite of what we think. The minus 6 shifts it down 6. And so, again, you can use your graphing calculator to do this. We're not going to. 1, 2, 3, 4, 5, 6. And so, if the square root had a vertex, that would be it. And then square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. And so that's the square root graph, looks like that. Alright. And we're moving. Cube root of 64. What times itself 3 times is 64? That's 4 times 4 is 16 times 4 is 64. Cube root of x to the 6. X times x times x is x cubed. X squared times x squared times x squared is x to the 6. Same thing with y to the 6 is cube root is y squared. If you think that this is y to the 6 and you're raising it to the 1/3 power, that works the same way. 6 times 1/3 is 2. And so then 27 times 1/3 leaves z to the 9th power. Because we're going to do 9 and 9 and 9. Okay. Simplify this. 8 to the 1/2 power raised to the negative 4 over 2. So we're going to multiply those exponents. And so you get 1/2 times negative 4 over 2. I can cross cancel. Well, and actually, let's just simplify this to begin with. This is 8 to the 1/2 raised to the negative 2nd power. And so 1/2 times negative 2 is negative 1. Anything to the negative power is when you take it and take the reciprocal raised to the first, to the positive. Or just 1/8, so you don't have to write the positive 1. Okay. 38. Key to remember, factor. You don't want to cross this out because they aren't common factors. It may be very tempting, but you want to factor it. So factoring the top left, you get x times x plus 3. Factoring the bottom multiplies to 8, adds to 6, x plus 4, x plus 2, times x plus 2, x minus 1. And it's got a 4 and an x squared that you can take out. And that leaves x, 12 divided by 4 is 3. And here comes the fun part. X plus 3, x plus 2. And then one of these x's. So that leaves your x minus 1 up top over your 4, 1x left over, and x plus 4.